event to this workshop, Sid?
Yeah, that is correct. We are on to the last but exciting event. So it's time for our second panel discussion. And the panel will be composed of the four speakers that you heard. So Nora, Spring, Dan, and Raphael. And then the panel chair for this session will be Professor Sabine Howard from the University of Bristol in the United Kingdom. I would like to just remind the participants that they can ask questions on Slido to our panelists. So this is your time to ask the difficult philosophical questions about swarm robotics. And also, please switch to the speaker view on Zoom, because that kind of looks better for a panel discussion. With that, Sabine, you're the ringleader. You can take it away.
Great, thanks so much for this wonderful workshop. I apologize, I could only come at the end because I was organizing a parallel workshop on micro nanoswarms, but I was excited that I could see those last talks. And it's great to have the speakers here for this final debate. So yes, the public, please ask questions. We'll make sure we ask that as we go along. And I thought I'd start with a little icebreaker. Do you think robot swarms are ready for the real world? Maybe just a yes or no? And I'll start with Daniel.
Dan Goldman?
Yeah.
Well, I think there certainly are robot swarms that operate in the real world. Depending on, I guess, what you call the real world. And that's what I tried in my talk to narrate. What kind of environments do you call the real world? You know, certainly in factories, that's a real world. I think it's a relatively simple pterodynamic regime compared to, swarms that, pterodynamic regimes that, let's say, ants, termites might have to encounter.
All right, great, fair enough. Raphael, just a short sort of yes or no. If you want to qualify that, that's fine.
Well, I would say no. I mean, there's possible to do some very simple things that are good for light shows, for example, that can be solved using choreographies, for example. But to solve more interesting problems that require especially interaction with the environment, I don't think we are ready.
Okay, good honest answer. Nora?
I would say that I agree with both of them. I think it depends is the answer, right? On what you consider to be the real world.
Fair enough. And Spring?
Yeah, I also agree that it depends. Depends on which domain it is, aerial, ground, underwater, surface, how complicated the vehicles or robots are, how long they have to be out, what kind of uncertainties they deal with. So yeah, I guess that's a pretty broad answer, but.
So it's worth us drilling in during this conversation. So I guess if anything, it shows that. So maybe I can start with you, Spring. Do you feel like we have the right mathematical abstractions for swarms, the right tools to start to model them in a way that they're helpful for the real world?
I think that's a good question. I think that I think that the mathematical models themselves can be broadened to account for, well, the physical realities of the environments that the robots will operate in. Like if there is, wind or ocean flow, well, some models already do incorporate that. I think it's, yeah, I guess there's the question of whether you want to improve the fidelity of your control-oriented models versus like apply deep learning and just, learn the features of the environment. And so I guess that's an open question in certain applications, but yeah, I think that more can be done to include, to develop the models to, make sure that the swarm performance is robust to various factors.
And for the other panelists, feel free to jump in anytime. It's not really meant to be a Q&A with me. So if you have a comment, you can make a sign or nod, and I'll try to keep track. I can see you all. So feel free to jump in at any point. Dan, I wondered if you could continue explaining a little bit where you think the potential and limitations are in terms of the physical aspects of these robots and getting them into these real challenging environments. Do you think we still have a long way to go to get some of these robots out there?
Yeah, you know, I think that from an individual robot perspective, right? Can a robot go from A to B or stay at B, subject to complex environmental and potentially swarm interactions? I, don't see a whole lot of robust systems out there that have that capability. Now, maybe, putting them into a swarm can mitigate some of that, but I don't know. That's what I can say to you. I think that certainly there are plenty of mechanical and environmental interactions which are unexplored, underexplored, and my bet is without better understanding of those will be still pretty limited. Again, the real world noise and complexity puts things in a very different, situation for individual robots and likely swarms as well.
So in your talk, you often show the insect inspiration. Do you think what allows them to do this is their own mechanical capabilities, or is it their numbers?
Yes. One of the things that we've become very clear, right, is that the idea that swarms or superorganisms or collective ants are somehow, composed of simple agents is laughable, in the sense that, nothing in biology is ultimately simple, is my kind of baseline, right? Like, you think an ant digging is just going to be something machine which uses its mandibles to pick up grain and remove, and then you end up watching them manipulate and sculpt soft materials in a way that our robots, can't possibly do. You study, you're trying to study how undulatory organisms move through complex environments, and you find that nematode worms are so far better than our robots by any metric, So I think that there's a whole lot to learn biologically, both individually as well as principles of collective. And I think if you neglect them either, you're going to be in trouble. Would be my bet. That's just.
Do you think that we actually need to model these animals with such high fidelity?
Well, that's a different question. I wasn't necessarily saying model. No, right. It depends on what you call model, right? I think that there are certainly principles that one can get at, right? That, how can I make a pterodynamically capable swarm of robots go and swarm into a tight, confined environment? I don't need to hopefully don't need to engineer something with the, complexity of a real ant. But I think that opening oneself to the possibility that there are cool principles to discover allows you probably to make more steps towards that. That would be my way to say it.
What do you think, Nora? Did you have another way of thinking?
No, I totally agree, and that's kind of why we developed that game, is because we really wanted to kind of understand what humans are doing and how they can accomplish these complex tasks on their own. And we thought, humans would be maybe simpler because we can actually ask them questions and have them explain to us what they did. But in fact, they're so complex that even humans can't really explain to you what they did. Like, they might tell you something, but then when you look at the data, that's not what they were doing, or that's not what it looks like they were doing. So there's a lot of hidden complexity, even if you can bribe someone with pizza or money to tell you things. But we don't need to do it exactly the way that humans do, and we don't need to do it exactly the way that ants do. We just maybe need to kind of pick up the principles that are necessary.
Yeah, that's why I tend to, and I tend to not, even though I'm an associate editor or whatever I am on bioinspiration and biomimetics, I tend to be somewhat leery of, I don't think of, so I'm a physicist by temperament and by training. And what we do when we make the robots is we make models to discover principles. It's less inspiration. I'm not inspired by an ant swarm to I'm really seeking to discover the principles. And if that happens to inspire engineers to design something, but I think that there's sort of an intermediate step between the organism and between the engineered inspiration. And that's the principles, which I think can be neglected if one goes straight from bio to engineering. That's my own hobby horse.
A question for you, Nora. I wonder if we are to deploy these multi-agent swarm systems in reality, what kind of standards will we need to put in place to make them usable by industry, for example, or convincing, a little bit similar to the way we've approached the autonomous car industry?
Yeah, I mean, that's a really good question. And like everything in multi-robot systems, I think is really application specific. I mean, ideally you have robots that can do a lot of different things, but the standards will certainly be application specific. Like if you're going to do kind of farming with a team of robots, and that's totally different than containing wildfires. Or so I think that's a really difficult question. I think that what we still don't really understand what's necessary in these environments for the team of robots. So it's kind of hard to say. But I think that, the things that are important are that we need automatic control synthesis, and we need, no hand tuning or very minimal non-expert hand tuning, because you never, in an emergency situation, you really don't want to have to wait for someone to show up. And, if you're doing interplanetary exploration, then that communication takes a really long time. So I think that those are kind of the key things there.
Something usable outside of the box. Rafael, maybe you can give us the insight from industry and how they see these swarms being deployable. How would they make them a reality?
Well, I agree with Nora's comment about the need to have to avoid tuning, the requirement for hand tuning every single agent, obviously. So that means I think that robots need to be able to self-tune or use learning on the real world to tune themselves and to improve performance over time, but they need to do that in a way that guarantees safety. So there are some techniques, mathematical techniques that are starting to be developed, or that have appeared recently in the robotics literature or in the control literature, that explore how you can guarantee safety even while the robot is still learning. And I think that's a really interesting area that needs to be also extended to the multi-robot case. And the other aspect that I would say is that we need to take humans into account and be able to interpret the intent from humans and use that information to proactively control the robots in a way that generates behavior in accordance with what the expectations of the humans would be in a given situation.
I'm going to jump in with a question from the public that aligns with this. So Spring mentioned learning, Rafael, you just mentioned learning, and the question is about deep learning and what you expect. The panel as a whole, feel free to jump in so what do you expect with deep learning and the development of next generation of swarm robotic systems?
I think it's a really important area, and there was in the first part of the workshop, there was some talk, for example, about graph neural networks. I think they are very interesting approach, for example, to solve some of the communication problems, because deciding what to communicate and to whom is really a critical aspect for multi-agent systems. And I think graphical or deep graphical neural networks are going to be to have a role in that solution, for example.
Anyone else want to react?
Yeah, I mean, I think that deep learning is entirely necessary, because we can't foresee everything, and there are a lot of unknowns. I think that deep learning will play a really important role in having robots kind of learn and adjust and tune themselves on the fly, like Rafael was saying. And the trouble is that I think we really need to better understand deep learning before we can, before we can deploy robots with that, because it's still a little bit of like a magical box. And I think that that's not gonna, no pun intended, fly for these types of tasks that we're talking about.
Another question from the public is, does a communication-free approach limit the potential of swarm robots? And this also goes in the direction of a question that I have, is a lot of you are highlighting that it's difficult, that the agents themselves need to be complex, they might need to learn on the go. Isn't there room for the very simple robots still that can make a difference and do something in the real world?
What makes simple robots not able to learn?
Okay. Yeah, that's a good point.
But I don't think communication free is, I don't think we should be applying communication free approaches where we don't need communication free approaches. I think that there's a place for them. I'm not saying that we should, overuse communication, but certainly communication can be helpful even when robots are learning, so that they can communicate things with each other and help each other learn faster. But I think that, the overuse of communication-free systems is not wise. When it's necessary, fine, but I don't think that we should impose it everywhere.
Okay, so I'm going to go to Dan and then to Spring. Dan?
Yeah, I don't want to make it seem like that I or we are advocating the complexity of individuals and their capabilities to learn necessitates the emergent features of a swarm. I think really this idea that the collective has properties that the individuals don't have can be leveraged as well. So I think that is an interesting trade-off in complexity of, or maybe not trade-off, complexity of individuals, complexity of tasks, and that interplay seems to be very interesting.
Okay, and Spring, simple robots. I'm thinking of your stochastic systems that work well in really large numbers.
Yeah, I think, well, I guess there's different types of communication that could be implemented. So, I mean, you can have them, explicitly using wireless communication or radio, or you can have, like a lot of social insects use what's called stigmergic communication, where they basically communicate through modifications of their environment. So it depends. I guess it depends what you consider communication. But I guess, I mean, there are certainly applications where you don't want, or it's really hard to have explicit communication, where you just have to rely on other types of modalities. Yeah.
Yes, I agree. I like the variety of swarms. I think there's place for both the simple ones that work in large numbers that might be communication free, and the more advanced ones depending on the application. Raphael, there's another question from the public here, which says, who should swarms be for? Who are the benefactors of these technologies, and what applications should we be focusing on?
Well, ultimately, I think people should be the benefactor, and so there were a couple of examples there that are very clearly in that direction, like the search and rescue, and the other one is the firefighting, for example. And I think those are very real situations that require that will benefit from having robots replacing people or cooperating with people to actually tackle these situations. So the objective is not to replace people here, but actually to be able to have swarms that are heterogeneous, that includes not only robots but also people in cooperatively solving problems. I think when you are able to take advantage of the qualities that people bring, or the abilities from people, and combine them with the abilities from robots, then that's when you really get some real benefits and some real advantages that you can use to improve and the life of everyone, hopefully.
Are there more mundane applications of swarms? I worry no one's going to see a swarm unless they're in a fire or in a disaster. I wonder where else could we see these swarms?
Well, we see them already, right? We see drone shows. You could consider that a swarm. So I think, you know, people are already benefiting by their entertainment.
Okay.
Yeah, definitely. Also, like delivery and transport, you know, aerial package delivery, infrastructure inspection, monitoring, repair. Yeah, so I guess those are kind of maybe the more advanced applications currently. I know, well, of course, during the pandemic, there seemed to be more use of robots in certain cases, like the UV light disinfecting robots, and there were little delivery robots running around the campus here. So if there was a motivation to coordinate them, you know, for larger scale applications, that, you know, public health might be another. I mean, fortunately, hopefully we don't have another one of these incidents, but I think basically any applications where, you know, it's dangerous, or, you know, dull, dangerous, dirty. But with swarms, I think the added capability is that you could do things over very large spatial scales and time scales. So you can really do things that you couldn't do with a single robot, right?
And if the public have any ideas, feel free to just dump them in the chat. Maybe we'll get a really great list of things that we could be working on as a community for the future. If we do deploy these in reality, one question from the public is, how do we check their safety?
That's a good question, and I'm not sure that we have an answer yet.
There's a lot of work going on in like formal methods for guarantees. And then also including controllers that incorporate neural networks. But yeah, it's still an open area.
But even the challenge with that is that you have these unmodeled events, right? So you can use formal methods, you know, and have provably correct controllers, but does that necessarily mean that you've taken into account every possible possibility? And that, you know, no, unfortunately, no.
I'm also thinking, Dan, maybe some of these robots, we don't need to be concerned about their safety of the crowd, because they might be smaller, simple enough that actually they're safe by design. Should we maybe change minds of people about swarms? I think that there's this connotation that they're worrisome, that we need to check their safety. Are there situations where we don't? They're just like little bugs?
I could certainly imagine situations where, I don't know, but certainly one could imagine situations where you have, you know, groups of entities. You know, I guess the question is, why worry about, you know, what's the worry here? The fact that there are many robots out there, the fact that they're operating under rules, emergent rules, the fact that there's individual, you know, what's the real broader worry here, right? The fact, I mean, pollution seems to me like the largest worry for swarms. You know, you're going to have gazillions of robots out there made of whatever, plastic, dying, sitting there. That seems to me like a big worry that could certainly be thought of. You know, imagine 3D printed swarms of robots in the ocean. There goes your ocean plastics problem again.
Make them biodegradable.
Again?
Make them biodegrade after their useful life.
Yeah.
Or they'll need to clean up more than they produce. Yeah.
Yeah.
Good. Maybe for those in the audience who might be starting out their career, I wonder if we could inspire them by maybe a cool moment in your career where you were really excited about something you saw on the screen, or a robot that you saw crawl across your table. So maybe if you can think about something that got you really excited, rather than the hard parts which we're discussing. So maybe Rafa, do you want to jump in?
Well, I can think of the Big Hero movie that where the robots self-assemble to to well, in this case, to do some evil stuff. So they showed very cool robots in that movie, and that was really interesting in terms of how can you actually do that. And at that time, where the movie came out, I was starting some exploration using these kilobots that from Harvard, that are very small robots that can only move in a flat 2D surface and communicate using only communicate locally and move through by vibrating themselves. So that was a lot of inspiration of how to through very simple rules and very simple capabilities for a single robot, you can obtain very interesting emergent behaviors.
Okay, and anyone else want to contribute an inspiring moment from their career or?
I think what got me, oh, I'm sorry.
Oh, go ahead, Spring. Go ahead, Spring.
I think what got me interested in multi-robot systems was when I was an undergraduate. I was on this like student technical magazine, and I was assigned to interview Naomi Leonard, who was working on coordination of underwater gliders. And I thought it was really neat how she was inspired by like schooling fish for you know, designing controllers for these gliders. And so I think it just started from there, just that concept.
Sounds awesome. Dan?
Yeah, you know, two things come to mind. Well, first, for any students out there who care or are interested, I'm basically doing in my faculty life what I was largely doing as a 10, 12-year-old kid, watching how organisms move and wiggle around and trying to build, you know, apparatus which helps me kind of either understand that or get at that. And I've sort of managed to turn it into a career, which continues to amaze me. But I would say that kind of on that backdrop, when I was a graduate student, so I'm a physicist by training, an experimental physicist, which I have to tell my engineering and computer science colleagues is actually a thing. In physics, we sort of speciated 100 years ago into experimentalists, people like me who go into the laboratory and make apparatus to try to either measure something in nature or increasingly measure something which we've created. And so this is a long history in, of course, solid state and semiconductor physics. And I'm hopeful it'll start to have a history in robotic physics applications. But so as an experimentalist, I got to work on a very cool system, which was about as simple a swarm. I didn't call it a swarm. I had never thought of swarms. But you take a bunch of sand, and you can do this at home if you have a speaker, a loudspeaker, and you put a little container on the inner cone of a loudspeaker and vibrate that container and pour sand in there. No individual sand grain is particularly intelligent or does anything particularly interesting. It falls and collides with the ground. So if you just put one sand grain in a container that's vibrating vertically under gravity, it'll just bounce up and down. 2 also bounce up and down. 10 bounce up and down. If I get 1,000 or 1,000,000 or 10 million, all of a sudden I go from something which is relatively boring dynamics to something which is emergently cool and complex. You can look these up. These are called Faraday patterns in sand, and you can get beautiful self-organized stripes, squares, hexagons, and then those things take on a life of their own. And that was my kind of introduction to kind of complexity and simplicity at times, emergent properties of ensembles. And then, you know, it's not a large leap to say, boy, if I can get such beauty and complexity of phenomena from sand grains, which all they do is collide and bounce off each other with some rule, what might happen when they can start to be a little bit smarter? So that's been sort of in my head since I was actually a PhD student.
It's neat. Nora, did you want to add anything or you're good? I think you're muted now. Or you're muted.
Okay, great. I think I'll give a more kind of recent experience. So when we were doing the Crazy Swarm, we actually had our dean come and he wanted to see it. So I wanted to put something cool together for him that was more interactive as opposed to like standing behind the net and just watching these things kind of move around in the dark. So we actually built a demo where you could walk through the swarm and they would kind of like move aside for you. And so I tested it out myself and it worked great. I just walked forward straight through the swarm. I didn't really do anything because I didn't want anything to break. And then when the dean came, he walked through and then he started walking like backwards and we were like, oh, what are you doing? Don't do it, don't do it. But everything worked out fine. So he was super impressed and then we were super impressed and also relieved that we didn't break the dean. But it was just really cool to be able to provide him and for me myself to have this very kind of interactive experience with our little drones. And that's kind of, stuck with me for quite some time.
That's awesome. I remember a demo we did with kids. It was with Roderick, wasn't it? At the Science Museum. And we had these kilobots at a table, like hundreds of them at a table, and we're like presenting the robots to them. And one kid just took a robot and chucked it across the room. And I thought, yeah, we really don't design for the way people think that, they'll use our system. So yeah, that's really neat. So we've got some questions from the public. I think this idea of inspiring got them going. So a couple questions here. Research is often far removed from impact. When in your careers have you witnessed the highest impact of your work? Like when have you felt it mattered? You don't all need to answer this one, but if one of you has a good example, that would be neat. And Raphael, if you want to jump from the industry perspective or your clients, maybe your clients have, they come with a problem and you're able to help develop a solution for that.
No, well, it's always great that there are people actually in industry that are interested in using the solutions or the algorithms that are some very theoretical or constructs that wouldn't seem obvious that would have value for some commercial application, but I can think of a direct example that has occurred to me.
I can jump in. So some of our work that I didn't talk about, we have a lot of like multi-agent pathfinding work. Sorry, were you finished, Raphael? I didn't mean to interrupt.
Yes, please go ahead.
So we have a lot of work on multi-agent pathfinding. And we also collaborate with Amazon Robotics. And so some of our work has been deployed on their systems, and I think that is actually really cool to be able to improve the package delivery, which I think still really needs some improvement, but I guess you can't really complain when you have like same day delivery. but that's one way that people are benefiting directly from this kind of research. Seeing their warehouses work is pretty amazing, but they still have a long way to go in terms of automation outside of the initial kind of warehouse where they store stuff. So there's still a lot of impact to be made, even in areas where we think that we've already done so much.
So if I had asked myself the question at the start, I actually think swarms are ready for the real world. And I feel like things are bubbling up with industry interest and where they see the need for multi-robots and they see that to actually do the tasks, they need more. And so the multi-robot, the swarm community sort of kick in. Maybe the impact isn't yet there, but it's on the horizon. I don't know if anyone wants to comment on that or just nod, and let's encourage those who are here to believe in it. I don't know, any comments?
I just wanted to mention, I think that swarm robotics just as a field can kind of serve as an intellectual bridge between different disciplines. like biology and physics. And in terms of impact, I think it's really neat to see like a paper from another field cite your work, and when it, you know, it's outside of the realm of robotics or engineering. So I think the impact can be multidisciplinary.
Great. And the last, let me just check what the public has asked. So so I'll combine a question from the public and a question we were hoping to ask, which is, what tips would you give to those entering swarm robotics now? What should, you know, think about your hardware, I don't know, whatever you think would be useful. And the question from the public also had to do with, are the skills that they're learning through graduate education useful? Which ones are the most valuable? So I think they sort of tie together. Who would like to start? Maybe Dan, if you don't mind putting.
Yeah, no, I don't mind. And in fact, I would say that and again, this is my physics background, but bring experimental robotics or robophysics or whatever you want to call it, elevate that a bit more. I think that my general belief and feeling is that if robots are thought of and conceived in silico and in theory, then we're somehow missing aspects of the real world which are important to understand and principles to be obtained. And so I think that I would make a push for less hardware and more kind of creative robot design, exploration in the physical and less in silico or in theory. In fact, Sid, one of our organizers, was on the receiving end of this diatribe when he was a PhD student, if I recall, on contact in robot swarms.
Yeah, I accidentally called an ant simple, and that was during my PhD proposal, and that didn't go well.
Yes, that was one, but he did a beautiful PhD proposal. But in addition, you know, this idea, if you're going to study colliding robots, then let the robots really collide, for example. And if you don't, then you're not really studying real world physical interaction. So that's my selfish take on moving the field. But again, I'm a physicist who in some sense is an interloper. I will say that engaging your local physicist may not be a terrible idea too. And some of Spring's work, for example, I know connects very strongly to beautiful work on PDEs and you know, Boltzmann type situations. So that's my tip.
Do you want to jump in maybe? So tips for the early career and skills.
So yeah, I'm thinking about how a lot of us converge to swarm robotics from different backgrounds, like Dan from physics and you know, from computer science, mechanical, electrical, engineering. I think probably what is useful is to have a strong disciplinary foundation in, you know, one or two of those areas that you can build on, because it's such a broad, swarm robotics is such a broad field that, you know, if you can pick an area that you're interested in, whether it's, you know, programming and algorithm development, or whether it's like continuum mechanics of soft materials, if you can have a strong foundation in that, you can certainly build on it by applying it to multi-robot problems. And then you kind of create you have an intellectual home, so to speak, like you have an identity of some sort. And it could be multiple identities, I guess, but just having that deep background, I think, helps.
I just want to say I agree completely with Spring. I think that's a terrific answer.
Any other thoughts from Nora or Raphael?
I think that kind of besides having a good foundation, I think you also need perseverance. I mean, it's not easy. It's not easy to get robots to do the things that we want them to do. As much as, you know, we think we coded them properly, we think we covered all of our bases, they always surprise us. So I think that perseverance is extremely important. So just as an example, the multiplayer game we've been working on now for like 4 years. So it's, you know, but I really believe in it, and I believe that that should be the not human inspired, but I believe that diversity is the paradigm that's going to make swarms actually work in these types of environments. And so I keep going. And I think that perseverance is really above many other things. It's not about what you know, because there are things that you can learn. It's about your willingness. And, you know, if you're just going to give up, then there's no point.
Okay, I think time is up, and that's a great note to finish on. So please all persevere and make robot swarms for the real world. All right, so back to the chairs, I think.
Thank you so much, Sabine. That was absolutely amazing. I thank the panel. I think we went from ants to deep learning to grad school. So really, that's exactly what we had in mind. That was amazing. Yeah, thank you so much to all the panelists.
Thank you for organizing.
Thank you. Gennaro, should we